Hello, I'm going to be going over some examples for conservation of momentum. So let's get started. We have two examples. One is in one dimension and the other is in two dimensions. So the first problem is a 60-kilogram woman standing on ice, meaning she has no friction, throws a 5-kilogram ball to her right at 10 meters per second. How fast does the woman travel? So the setup of this problem looks like this. So we have a woman throwing a ball. She has a mass of 60 kilograms. The ball has a mass of 5 kilograms. They're both initially at rest. So their both initial velocity is 0. But we know that she throws the ball to her right at 10 meters per second. So the ball's final velocity will be 10 meters per second. But we don't know how fast the woman travels because we need to calculate for that. So to start, we know that the momentum of an initial situation is equal to the momentum of the final situation. So basically, because momentum is mass times velocity, we know that m1v1 and m2v2 of the initial situation is equal to m1v1 and m2v2 of the final situation. That's what this apostrophe means. So when we plug in all of the information that we know that initially her velocity and the ball's velocity are 0. So this right side is all going to be 0. This is all equal to 0. And understanding that, we can move this m2v2 to the other side. So the equation becomes negative m2v2 of a final is equal to m1v1 of the final. So knowing these numbers, m2 of the ball is 5 kilograms. v2 of the ball is 10 meters per second. And m1 of the woman is 60 kilograms. We don't know her v1. So just solving for v1 shows that v1 is negative 0.83 meters per second. And it's negative because she's going in the opposite direction of the ball, which is the positive. Okay, so that's our first problem. So that's pretty easy. So the second one is in two dimensions, so it's a little bit more complex. So an asteroid of 1 kilogram with a velocity of 5 meters per second hits another asteroid of 2 kilograms at rest. The first asteroid shifts up 60 degrees on the x-axis, and the second asteroid shifts down 30 degrees on the x-axis. What are the final velocities of asteroids 1 and 2? So the situation looks like this. So you have an initial situation and a final situation. Your initial situation shows that the mass of the first asteroid is 1, the mass of the second asteroid is 2, the velocity of the first asteroid is going to hit the second one at a velocity of 5 meters per second, and the second asteroid starts at rest. So these are all the initial points of information. Now the final points of information, all the masses are going to be the same, but we don't know the final velocities of these asteroids. We just know the angles that they end up traveling towards compared to the x-axis. So when we know the angles, we can use trigonometry to figure out the rest. So the angle of the first asteroid, we can use the angle to find the final velocity because we know the x and the y components of this first asteroid. So the x component is going to be horizontally, it's going to be equivalent to the magnitude of the final velocity cosine the angle. So the angle is 60, so it's going to be cosine that angle. And same thing here for the final velocity of asteroid 2 on the x-axis. It's going to be the magnitude of velocity 2, final, cosine 30. So it's 30 degrees right there. So we would replicate this for v1 final y and v2 final y, except it would be sine 60, and it would be cosine negative 30 because it would be going negative on the y-axis. So knowing this, we can plug in for our momentum. So we know that in any situation, the momentum of an initial is equal to the momentum of the final, And this is true of both the x and the y axis. So we can solve for the momentum of the initial and final of the x-axis first. So when we plug in our numbers, we get the initial momentum, the mass of the first asteroid is 1 kilogram, and then it hits with an initial velocity of 5 meters per second. The mass of the second asteroid is 2 kilograms, and it is at rest, so it is at 0. And then over here, your final momentums are as follows. You have the same mass, but your final momentum is, like we said with the chart over here, your final momentum is going to be the velocity final of asteroid 1 cosine 60 plus your constant mass of asteroid 2, velocity 2 final cosine 30. So you end up just calculating with your calculator cosine 60 times 1, that's going to be 0.5, and then you have this V1 final as a constant, as a variable. So you bring that down as well. And same goes for here. You calculate cosine of 30 times 2, and you get 1.73, and you bring down this V2 final, and you get this equation. So we're not going to touch this equation yet. We're going to use this equation later on. So this is for the x direction. For the y direction, it's pretty simple and basically the same thing. The initial velocity in the y direction is nothing. There's no initial velocity. So it's 0. So this entire side is 0 for both asteroids. Neither of the asteroids are moving at a velocity in the y direction. They're not moving up and down. When it comes to the final, we use the y component of the final velocities. So you use your mass, your 1 kilogram of asteroid 1, and your y component is going to be the initial velocity, the final velocity of asteroid 1 times sine of 60. The mass of asteroid 2 is 2 kilograms. And then your final velocity of asteroid 2 times the sine of the angle, which is negative 30 because it is going down on the y-axis. The initial velocity, so the final velocities are going to be 0.86 V1 final plus -1 V2 final. And using some pretty simple algebra, we can conclude that V2 final is equal to 0.86 of V1 final. So we can plug in this V2 final for the equation that we just got while trying to find the x direction. So you plug in for V1 final. So in this original equation that we got, we have this value of V2 final. We can substitute it so that everything is all one variable and we can solve for all one variable. So when we plug in V2 final, we get this value, and then we just use some algebra to calculate for V1 final. So that means that V1 final is 2.5 meters per second. And then now that you have V1 final, you can calculate it, you can plug it back in for V2 final. So V2 final is 0.86 V1 final. You just plug in your V1 final, and then you get your V2 final. So now you have the velocities of both asteroids in the final step, just using the angles and the initial velocities in the mass.